And we're going to continue with our next speaker, Mihai. Are you online, Mihai? Hey,
Hello, I'm here.
how's your day?
Nice to see you. It's good.
It's good to be a Java architect, Java developer, right? So,
Yes, hands-on.
okay. So, what are your plans for today?
Well, I'm going to talk about the developer experience. I see that the previous presentation already had CI/CD in it. So let's continue along this line and let's talk about the workflows and what is considered to be modern.
Okay, we have a deal. So we can share screens and good luck.
Okay, let me see. I would like to share my screen. And that's it. Can you let me know if you see my screen?
Positive.
Okay. Then, let's begin. Hi, everybody. My name, as you were able to see on the invite, is Mihai Ionita. And I've been a solution architect with ARC Systems, Computaris, for many years now. I'm doing hands-on dev and ops. And over these years, I've seen a lot of changes happen in this area. So today we'll talk about continuous workflows, continuous everything, like I call them. The most known parts are CI and CD. This will be about the tools used and the experience so far. Of course, with an emphasis on Java projects. I would like to take this opportunity to remind you about our tech quiz, where the best answer will be awarded an e-scooter. And you are invited to ask questions in the chat area, where me and the colleague, Elia from HR, will be available the whole day to answer them. So let's start with some generic stuff. What is the first rule of shared code repositories? Well, don't commit code that will break the compilation. And the reason is pretty straightforward, of course. The code that does not compile will prevent anybody who pulls that code from progressing. Next, what is the desire of CI? To integrate code into the shared repository frequently. Now, this frequently is up for debate, but the code, once integrated, will be built automatically and hopefully, but not implicit, will be tested automatically. Not implicit according to the definition. So, is it up to you, the programmer, to build the code before you commit, or should you rely on CI automatization? Well, before the DevOps or the DevSecOps merge, it was clear. Compile your stuff locally and then commit. Now it's not so easy. You may compile the module you're working on, but when it gets compiled as part of the whole project, side effects may show up. Now, it is no longer enough that your jar file, let's say, gets generated. By the way, before this jar file gets generated, that's where CI ends. It also needs to install successfully too. This is the CD part. Still, this doesn't mean that you should commit completely broken code. It just means it's easier to break it without noticing. Just a clarification here. My view is that DevOps is more about people's roles in this whole story, while CI/CD is about the actual processes. I just felt the need to state that because there are many definitions floating around. So, we talked about integration. Let's see about CD. First, what is the D for? What does the D stand for? Deployment or delivery? Well, according to Wiki, continuous deployment requires continuous delivery. Meaning, in order to install that jar file, you first need to generate that jar file. The only thing which seems to be consistent in continuous delivery is the fact that any version could end up on the customer's system. Well, unless you broke that build or the test. See the previous slides. So, what makes CI/CD good? First of all, if compiling and testing takes literally the whole night, well, I may be sleeping by the time it tells me that I broke something. Plus, it's kind of breaking the mojo. I'm here, I want to code, I want to fix my code today, not tomorrow. And from a reliability point of view, I don't want it to crash because it's put together with, how was that, grit, spit, and a whole lot of duct tape. Not everybody from the dev side embraced the ops part yet. I may not know that, I don't know, a tab character kills my YAML file or how to fix a parameter that changed with the new Kubernetes version. We had this experience while trying to do a kube control get pod with a JSON output. Well, the metadata name changed. The advantage of having an established CI/CD line comes in pretty early. So let's consider, for example, taking over a new project, either internally in the same company or from somebody else. Ever found yourself in the middle of dependency hell, like not talking about Linux packages dependency hell, but rather do-it-yourself kind of hell? Install this, then you need to install that, then you need to compile using that command line. Well, while you go through the README files in each sub-project, you may encounter contradictory references depending on how old each file is. It may happen that the time between formal takeover and first successful compilation, not to mention test run, is quite long. And how to run the unit tests. Do they have any dependencies? Do they run both from the local machine and from the Jenkins task or whatever other way there is to run them? Well, unit tests should rely on mocks and be able to run anytime, anywhere. At least that's the theory. So I've been through this, and yeah, the first thing that I look in a new project is I want to see a relatively short README file. I want to see how to compile and run locally, how to find a CI/CD pipeline, and where, by the way, where the pipeline writes the artifacts that are produced. Okay. What about the small stuff? What does small stuff mean? Well, for example, I may be struggling with a pesky regular expression and simply cannot get it to work. And let's say my input is coming from some external system. Of course, you will tell me that my function should be atomic and readily testable using JUnit, but what if it's not? What if for historical reasons, if nothing else? Well, it would be good to be able to make a small adjustment and, I don't know, quickly redeploy either locally or remotely, but it must be fast. So, enough with the generic stuff. Let's see some of the problems we encountered. Well, first of all, some of our customers have their own code repositories, and they don't appreciate us stuffing them full with ops-related scripts. Next, Java. Not exactly Pony Express when it comes to compilation time. Maven actually makes it worse. Gradle is a bit better. Yeah, depending on experience. Next comes deployment speed. So depending on whether you want to create the whole test system new, your deployment speed may vary based on the technology. And here comes the fight between containers, VMs. Clearly the VMs are losing it. Next one, running a local component. Well, like I said earlier, it may happen that you don't have components with readily available mocks all around it so that you can run it locally. And the next one is about long-running test systems. I'm looking at virtual machines for this one. You may have just, I don't know, upgraded that Perl version that accepts your new code on the test system only, and surprise, your production system doesn't work. And the last one, let's see, reporting. Well, everybody loves a good report full of past tests. So, just a short recap. The problems I mentioned so far are those encountered when you already have a CI/CD line. For example, the separation between project code, dev, and ops stuff. Well, it doesn't exist if you don't have any ops to talk about. You just have a, I don't know, a README file telling you these are the prerequisites that you have to install and this is how you should compile. Then you're off the hook, but yeah, it's not the case anymore. And now let's take a sample project from the telecom world. It's a pretty old one, albeit with several rewrites along the way. So let's see. We call it an ecosystem, which is just another word for microservices ahead of time. Well, they are not so micro, rather services. And we used to deploy them multiple per host. Now it is down to one per host or container. We have dependencies, a lot of them. Why? Because no mobile operator, no telco provider, whatever you want to call them, will replace their entire stack of applications at once. Plus, there is no single vendor for all. I don't know, you may have the call control from Metaswitch, the charging from SAP, your soft switches may come from Sonos. Most of the time, you won't even replace all the applications inside the project at once. It's simply too much for the customer's team to evaluate in one go. So you will change one component and then another, and have different releases. So let's see our sample project. I'm not sure if you are able to see my mouse, probably not, but anyway, I'll talk you through it. First of all, on the left-hand side, lower, it's front end to control some settings. Then on the upper side, we have the external telco equipment, which is sending requests to our gateway, which are then passed on to the backend, which queries some databases. For example, this one, HLR below, means home location register. And it basically holds your subscriber data. And then it pushes some result to a partner enterprise on the right-hand side. or even to some other telco equipment. I chose this example because it sits right in the middle between what you see here as external and partner. So between entities provided by other vendors, and is therefore most prone to the usual problems of unit and functional testing related to mocking the systems that it interacts with. So, what does this sample project comprise of? Well, we have the databases, mainly HLR, that I mentioned before, HSS, Home Subscriber Server. This came a bit later. You can look them up on, I gave you the wiki links here. We have the front end for the operators engineers or I don't know, support personnel to change some configuration values. We have the backends which process and send processed info to the external system. We have storage here based on Cassandra. We have statistics with the ELK stack, Logstash for pulling the files, Elastic for the aggregation, and Kibana, the interface. We also have a message queue for the requests. The message queue is, by the way, built in Java. It's not ActiveMQ or anything, it's some proprietary one. All of this is supported by a functional test framework. And yeah, as external systems, you can see here some of the elements that trigger events, policy and charging function, SMS center, GPRS network, the support node. So this is a telco project, so not really relevant for everybody. So let me just provide you with a simple use case here. The gateway for data, the GGSN, gateway GPRS support node, sends an event, reduction in QoS. The user has surpassed a certain threshold. You may be familiar with this. I don't know if you have a subscription with a mobile provider and you have an allotted, I don't know, 10 gigabytes per month or so. Afterwards, you don't get disconnected, but your speed drops to some unbearable. Maybe I was a bit too over the top here with 256 kilobit. I'm not sure what they downgrade you to these days. But, anyway, that's our use case. So we have a reduction in QoS. So we are receiving the request from GGSN. We are checking some stuff. We are checking your subscriber profile from the HLR, from the database, and we are sending a request to PCRF telling it to downgrade your quality of service profile to 256 kilobit. Meanwhile, we inform the partner. The partner may be, I don't know, anything from a company providing internet access in a plane to pretty much anything. This way, the partner is informed and is able to, I don't know, for example, show the subscriber a captive portal. You've got this page, you can upgrade for another 2 gigabytes for, I don't know, €1, €2. Or at least you get a notification on SMS. Now, let's see what our previous deployment looks like for this sample project. We are talking about test and production deployment for this project. And we were using an OpenStack with orchestration done in two ways. One of them was Heat and the other one was Terraform. The choice of OpenStack was mainly due to, for those that don't know it, OpenStack is about private cloud. It's a private cloud offering you the ability to create virtual machines and a lot of other things, but mainly that. So the choice was due to having available local hardware and due to security concerns. After all, this is telecom, and security is pretty important. Since heat scripts are quite, templates are quite standard, I'll show you where we were with Terraform and show you a couple of sections from the template Terraform file. For example, an image, we had usual image, the SSH key, and the compute instance, which was created using that image and the key. Of course, the file is much longer. This presentation is about the tools, the process, not about a specific example. But we'll see later. And this one was the script that was populating the template. We chose to get the available data from the OpenStack RC file, that is the file that you source at the beginning in order to use OpenStack, and you get the user tenant authentication URL and so on. And you may notice something else here. We do a wget on the image, and immediately we do an OpenStack image create without any change to the image whatsoever. So we use the images as they are provided by the vendor. The vendor may be, I don't know, CentOS or pretty much anybody. So no processing, pre-processing. And then we plan and do the apply. No need to tell you how long this whole process took, so pretty long. And when you're done with it, you find out that your cloud init is not enough for all the ops that you want to do, like change configuration files, install new software, etc. And in comes Chef to help you install the rest of the way, the rest of the software that you require. So, just a note for those of you that must use or plan to begin using OpenStack. The way I remember it, the release schedule for OpenStack was once every 6 months or so. This means that by the time you get to work on an OpenStack installation, it will probably be superseded by some new version, which is good because it allows third-party tools like Terraform to implement the new APIs. I recommend using Terraform for the reasons specified in its documents. So it allows you to move between OpenStack, Amazon, AWS, Azure, and so on, other providers with relative ease. Well, the keywords are not the same. The compute instance will have a different keyword, but the template should be quite similar. And for the fans of Go language, you can use your favorite language to describe the template. So in order to get started, it's pretty easy. You just look up Terraform template GitHub on search engine, and that's pretty much it. But of course, if you need to work on the bleeding edge, on the latest and greatest OpenStack, it's good to use Heat templates because they are OpenStack's own and they provide you with the latest set of features. Okay, and this is what our OpenStack Horizon, which is the GUI for OpenStack, looks like on our test system. Well, with a virtual machine, you always have the cost, time-wise, cost to bring it up in mind. So you wonder if you really need to bring it down, or you could reuse it by installing some new software version on top of the existing one. And that is when you go into the unreproducible behavior area. Well, the approach is pretty simple. You have some ephemeral root drive, which gets recreated on each deployment. And you have some cinders, which are permanent storage drives. where you want to keep your config files, log files, whatever you want to keep. So in order, for example, to mimic the current container behavior, probably you would only want to use the ephemeral drive. But then again, it boils down to how long it takes to spin up. And now, let's see. By the way, you should be using a yum repository if you plan to install RPM files or similar for other distributions. There is no clear-cut way to copy files directly into the image, unless you change the image before deploying it. But enough of the old stuff. Let's see what our current deployment looks like. Moving to containers, we went with OpenShift. So that's what our pods look like in one of the test instances. This means that every time we start a CI/CD pipeline, everything is newly built and deployed. We chose this approach in order to have a local implementation, again, due to cost and security concerns and due to availability of a budget for the physical machines, after all. This means you don't have to worry about renting costs, but still you need to watch the efficiency. You want to make the most out of this infrastructure that you have. Well, about getting started tips, I cannot really provide any getting started tips here. I'm not into the OpenShift admin business, but for your work from home projects, I would strongly recommend K3S, so half of Kubernetes, K3S, and I installed it and it was relatively straightforward, and I love the fact that the components like GUI statistics and so on are all running inside it in pods. I installed it on a virtual machine in the cloud, so I have an extra cheap version of containers, meaning that you may get it to work for less money than it would take when you rent containers straight away. Of course, you have more work. You need to install everything and manage everything. So, what does this solve? Well, this is the list of problems you've seen earlier, and these are the problems which are solved, the ones which are crossed out. What is the point here? For the deployment speed, you may not care about the time it takes to deploy a small project, but as small companies tend to do away with hosting their own hardware, you will find yourself in the position of having to justify the size of virtual hardware that you want to rent from a cloud or wherever for a particular project. The other thing is about long-running test systems. Of course, you may choose to rent virtual machines and simply redeploy without bothering with containers, but do you really want it? Do you really want to install over and over again on the same operating system multiple versions of your software? Your system may end up in a state where you don't know where that error came from, whether it's you, whether it's some library which got updated. So, what we are currently running with is a Jenkins server with a pipeline, with a shell script behind it. The advantage of the shell script is that it can be versioned and stored in a code repository. And you can see here we're preparing the environment, we're setting the kube config, we are starting the container, we are waiting for the container to be up, then we are installing the Maven environment on the pod. Of course, we have a Maven repository here, the address of which is in the settings XML, from where the compilation can pull the artifacts. Jenkins is old news. Probably everyone has heard of it, so no getting started section here. Basically, we run a container where we compile the component and unit test it. The purpose is to avoid using whatever Java version you have installed on the Jenkins machine. That Java version may be pegged to the Jenkins version. If you upgrade Java, you break Jenkins, I don't know. So instead, rely on a freshly installed Java inside the container you just created. We use Jacoco for coverage measurements. And at the end of the Maven task, we pull the Jacoco exec files. Coverage of unit tests is one of the few, but synthetic measurements, which can give you a quantifiable way of telling how well you expect a software to perform. There are multiple frameworks available. It's just a matter of choosing the one that fits your requirements. In our case, we'll see in the next slides why it was Jacoco. By the way, as a getting started tip here, if you want to get started with Jacoco, you simply have to create a Java project, add some JUnit, add some Maven or Gradle nature to the project, and then look for something like Jacoco coverage example on the internet. By the way, there is a very nice Eclipse plugin for it called ECL Eclema. But let's continue here. What does this solve? We now have a separate project for the code and for CI/CD. You may ask, why do you bother? Just keep it all in there. Well, it depends on what you need to deliver. You may find yourself delivering software the old-fashioned way, in a jar or in an RPM file. This doesn't have to stop you from implementing a good CI/CD pipeline for your test systems, at least. Production systems are finicky. You have all sorts of limitations on what you are allowed to do, especially automatically do, but the test systems, on the other hand, everybody would love to have them provisioned with the new software version as fast as possible. Then what's next? We build the Docker image and we push the Docker images we created into Nexus. We use Nexus Sonatype repository. I mean, the same way that you wouldn't collaboratively develop nowadays without a source code repository like Git, Bitbucket, GitHub, GitLab, whatever. The same way you wouldn't want to go without a Docker image repository. On a side note here, like going back in time a bit, we didn't go directly from virtual machines to Kubernetes. We had an intermediate stage, Docker Compose, or may I say Docker Stack similarly, but Docker Compose is more interesting because it allowed us to build the containers directly from within the Docker Compose YAML file. So instead of pointing to an image, we pointed to the Docker file. However, this can open a can of worms by allowing you to ever so slightly have different images where the difference could be as little as the version number inside the config file. I believe that firmly separating the container building process from running them forces you to find better solutions in order not to fill your systems with a large number of images with very little differences between them. Now we continue the pipeline. We run a suite of functional tests using the Kubernetes test tool. This is a JMeter-based tool with some additional plugins on top, telco related, most of them. And for the functional tests to work, we run containers from all the images that we created earlier. This is what the Kubernetes test tool looks like. Well, it's blanked out, most of it, but you get a feel. It allows you to provision all the necessary data by sending requests with subscriber data. You provision the requests to, you send provisioning requests to network elements. And finally, you send the actual test requests, the ones that you want to test. All of it can be written using Groovy scripts. It's basically an gain experience as you go kind of tool. So it allows you to start with simple projects. I think they are called projects, files which put every operation together. You have a link on the previous page anyway. Basically, it allows you to send any kind of request from plain HTTP to SOAP to diameter, multi-threaded. It has configurable ramp-up time, speed of requests, number of threads, everything. The best way to get started is to look for some sample JMX files on the internet. At the end, we pull the Jacoco files, the exec files, from the functional tests, and we put them together with the ones that we had from unit testing. And the next step is to create a coverage report. You can see a command here using the Jacoco command line interface. Now we come back to the Jacoco choice. Our build coverage for the sample project is a mix of unit and functional testing. Without each other, they would not be enough. So it's very important to be able to combine the results and report on the code lines covered by each, or covered by both, why not? HTML output is useful, user-friendly, providing all sorts of statistics. So here is a sample flow for the coverage. We have like 5 workers. Workers means, for us, it means full software deployments separated in different namespaces, each worker with multiple pods. I think it's 9 of them in total. So we take the Docker images from the Nexus repository, we deploy them on each worker, then we run in parallel multiple tests with the test tool. When the tests are finished, we extract all the Jacoco files from each pod and we generate the code coverage report. And we archive the logs. Currently, we are still using a Docker daemon running on the Jenkins machine. However, we are moving, in the process of moving to Canico. See this bold line here. This will allow us to have fewer dependencies on the software installed on the host machine, meaning that you only have on the host machine, on the Jenkins machine, you will only have the software needed to run Jenkins, nothing else. And then you can easily move between Jenkins, GitLab with its GitLab runner. I know migrating between frameworks is not easy, but especially for large projects. The best way to get started with Canico for first-time users, I think, is to look up those words, official Canico tutorial on the internet. One more problem solved. We now have a consistent report. Well, I guess many in the audience have a coverage report as one of the deliverables for projects. So it's not something strange. Now that we have seen the pipeline, let's go back to our sample project and discuss how we can test it with some sample tools, both locally and remotely. What does it mean locally? Well, the test tool is run locally with a GUI. I mean, most developers nowadays use some GUI on top of the operating system. I mean, Windows, KDE, GNOME, XFCE, whatever. And behind the scenes, our partner on the right-hand side replies with some predefined SOAP JSON diameter answers. So remember our example with reduction in quality of service after surpassing a threshold. Well, in this case, it will be diameter Rx, the protocol used to communicate with the partner. The partner in our case will be the PCRF. That will lower the quality of service. Now, remotely, functional testing of single flows. What changes is really the way we run the test tool. This time the test tool does not have a GUI, it is scripted, and this is the way to do it for unattended runs like nightly test or similar. It's usually done after you locally made sure that things are working okay-ish. It's much easier to work with a GUI in the testing tool rather than have a script run and then at the end you look through the log file, see what crashed, if something crashed. And for testing all the components, testing complete flows, this is done mostly for the release builds. As an example, we have around 500 end-to-end tests. Actually, I have real numbers here. In order to get a reasonable runtime, we are running 5 workers for the nightly builds and 10 for the release. A full run of 500 tests takes about 1 hour, so more specific. 1 hour and 19 minutes for 536 tests on 10 workers. So 10 different namespaces in OpenShift. Well, having discussed the pipeline and having seen how it applies to our sample project, we come back to this earlier slide about reliability. So, see the bold text here. Isn't this pipeline about a lot of duct tape? Well, yes, and although if you have well-written scripts, they can be very good. The main problem is when new people have to come in and take over some part. Scripts sometimes are like Cinderella. I mean, they receive very little attention by default. Not to mention the whole review and test iterations, forget about it. I'm not sure why. I guess people tend to consider them like a temporary solution, but as I'm sure we all know, temporary solutions tend to become rather permanent. And this is where Skaffold comes in. The text you see here in blue on the right lower corner comes from the Skaffold website. Well, now, Skaffold provides the pipeline, albeit more standardized and without the classical scripting pipeline. It will effectively replace most of our in-house Jenkins pipeline. For the Java compilation part, we have the Jib builder, which takes care of either Maven or Gradle natures. The rest, like Docker build and kube deploy, they are Skaffold native operations. And it has several ways to run it. First of all, let's see the profiles. Here you have 2 profiles, one of them for the nightly build, the one on top, and another one for the statistics. So you can separate things, much like you have profiles, I don't know, in Gradle or in Maven. The same way goes for Skaffold. And this is the run pipeline for Skaffold. This is something very good to use in a pipeline, in a CI/CD pipeline. But coming back to this slide about the small stuff. Using Skaffold running in, you can see here, dev mode, you can task it with monitoring of the source code files. So whenever there is a change in your source code, the build pipeline is run again. This allows you to have that local environment. By the way, thanks to Docker Desktop and Kubernetes enabled in it, with all the necessary dependencies around the component that you are debugging. all of them in Kubernetes pods. And I'm not talking mocks here. I'm talking about real components. And yeah, for Java, we have that jib builder. For getting started on Skaffold, just create some sample Java program with Gradle, some unit tests, yeah. And have the program run an endless cycle, doing something simple. I don't know, add a shutdown hook if you want. Then you add the jib plugin to your build Gradle file and run it with Skaffold. I mean, there are tutorials available for all of this. One more problem solved. So debugging a component by running it locally. You see, I have also crossed out the Java compilation time. This is not directly addressed, but at least it's now local and allows you a quick turnaround, meaning you see your code fail quickly and you are able to provide a fix just as quick. So what is the point here? The point is to ensure the complete testing environment. So have local testing, have remote testing with GUI test tools, sending requests, and have remote testing with scripts. And the remote testing with scripts has to be on a reproducible environment. So best if it's recreated every time. And of course, it has to be as fast as possible. Don't break the mojo, like in one of the earlier slides. I don't believe there is a single tool that will enable you to have a modern developer experience, but rather a collection of tools. Their use depends on the size of your project, how old it is, what are the customer's priorities, as well as your own priorities. And I believe that your own priorities are the ones that set the pace of your code development activity. So, like I mentioned earlier, at least the test systems are mostly within your reach. And another reminder about the quiz.
Looks like we have the same picture. The one behind me and the one on the screen, right?
Yes, correct. I'll
Yes.
change it. Now you have the thank you image on my screen.
And thank you, Mihai.
And thank you for having me.
Well done. We've got a few questions, of course.
Okay.
First one, any improvements in plan for what you've just explained?
Well,
I mean, it's very good, but I don't think it's perfect. I mean,
yes, like I mentioned, the best, well, you always start with your development environment and your test environment, because those are mostly in your hands and you are allowed to do whatever you want with them. Basically, you break it, you fix it. The next improvement would be going to the production system with the pipeline and everything done in an automatic fashion. This allows, most of all, this has a human influence, so it makes people more aware that whatever they produce is going directly to the production system. And of course, it forces you to add a few more checks in between to make sure that nothing happens. So it goes like this: dev, test, and production. That's the direction. And with regards to tools, I mean, we are always looking for new tools. There are other things like Travis CI and a lot of other tools. I mean, it's an inflation of tools nowadays, and we are constantly exploring everything that the market has to offer. And we are evaluating them from a telecom perspective.
Any particular improvement in mind on your roadmap? I'm sure there's a lot to improve for sure and modernize and so on. But if you were to name one thing.
One thing, scaffold all the way, so remove the custom scripting.
Okay, okay, thank you. There's another question related to security checks. Do you have security checks in your pipeline?
Yes. However, security checks are mostly coming from the telco operator, from the mobile operator. So they have some specific checks in mind, and they usually prefer to do it themselves. And of course, we are always trying to help them by making sure that we provide some automatic way to deploy these checks.
All right.
And currently, yes, we are helping with scripts to enable these checks to be performed on a nightly basis, if possible.
I'm sure this is the right and the expected answer, for sure. By the way, there is a comment from the audience that your OpenShift thing looks very cool. Looks
Thank
good.
you.
Just explain. And now, Mihai, for an e-scooter, I've got a question for you.
Okay.
Advantages of Kubernetes resources compared to OpenStack flavors. You know the question?
That question is part of the quiz. So I'm looking forward to see as many answers to that as possible, and we'll try to
There are two
grade
questions
them.
there. So should we try to solve a little bit right now? Give us a hint.
A hint. Well, you can start by looking up the flavors and resources. See some examples, compare the examples, and then tell us what you think.
Okay, Mihai. So during the break, I'll take the chance to make this comparison, and then I'll probably.
Okay, good luck.
Okay.
To you and
Thanks
everybody.
again. We're looking forward to have you next time in the next editions of Code Camp. Well done for today, and until next time.